Hi there, welcome to Imaginary Numbers. You've probably seen this before. If not, here is your introduction. I is a nice little neat way of dealing with the square root of a negative number. Up to this point in time, you most likely have heard that you cannot take the square root of a negative. I lets us deal with that now. So as you can see, this is just kind of a given. If you accept this, the rest of it should be a little bit easier to understand. I equals the square root of negative 1. So we can kind of cycle through this thing here. I could take a look at I squared. Okay, if we know what I is, well, we can just square it. So what that means is it is the square root of negative 1 times the square root of negative 1. Another way of showing that, the square root of negative 1 squared, and you can see that those cancel each other out, leaving you with negative 1. So I squared equals negative 1. We can keep on going down the line. We can hop into an I cubed there. Well, I cubed could be broken up as an I squared times I. Since we already know what I squared is as negative 1, we're just kind of doing some substitution here. Negative 1 times I, negative 1 times I would be negative I. So I cubed is negative I. Continuing down, if we hit the next one, I to the fourth, well, I to the fourth could be broken up as I squared times I squared. Each I squared is negative 1. So it's negative 1 times negative 1 equals a positive 1. That is the cycle. That's what you were looking for. So to summarize this, I equals the square root of negative 1. I squared equals negative 1. I cubed equals negative I. And I to the fourth equals 1. So each 4-pack, each I times I times I times I actually equals 1. That allows you to simplify quite a few things here. First things first, let's take a look at a very standard square root of negative 4. Previously, you probably said you can't do that, but now we can actually do that. So the breakup of this, the visual, would be the square root of 4 times the square root of negative 1. Getting back to your rational rules, you are allowed to separate and combine with that multiplication there. So we've separated into the square root of 4 times the square root of negative 1. Square root of 4 is 2. Square root of negative 1 is I. So therefore, the square root of negative 4 is 2I. Square root of negative 9, kind of the same thing. So the square root of 9 would be 3. The square root of that negative would be I, 3I. Square root of negative 100, well, the square root of 100 would be 10, and what would be left over would be the square root of that negative 1, leaving me with I right there. There we are. So let's take a look at I to the 16th. So what that is I times I times I times I 16 times. I don't really want to write out 16 i's, but knowing that each I to the fourth is 1, it allows you to really kind of simplify this down. So if I were to take a look at 16, I want to really figure out how many 4-packs are in there, because each 4-pack is equal to 1. So if I were to break this up, I could rewrite it as I to the fourth times I to the fourth times I to the fourth times I to the fourth. Well, each one of these is 1, so it really ends up being 1 times 1 times 1 times 1, which ends up then simply being 1. I to the 16th is 1. Well, is there a better way of doing this if my numbers get larger and I don't want to write out all these different 4-packs? The answer to that is yes. What you want to do is you want to divide the exponent by 4. Remainder is the new exponent on I. Whoop, that was a J, pardon me. On I. So really what I'm talking about here is I would take this original exponent of 16 and I would divide it by 4. Goes in there 4 times, 16, evenly, 0 remainder. So 0 is my new remainder on I. So if I were up here, I wouldn't be dealing with I to the 16th, I would be dealing with I. And my remainder is 0. Anything to the 0 power is then 1, and we get the same result right there. How about I to the 21st? Well, I'm looking to see how many 4-packs are in there, because each 4-pack is equal to 1. So how many 4-packs are in there? You're probably saying, oh, there's 5 of them with a remainder of 1, and you are correct there. But what we can do mathematically is take my exponent of 21 and divide it by 4. 4 goes in there 5 times, 20, remainder of 1. The remainder is the new exponent on I, so really it is I to the first, and I to the first is simply that. Just I. So I to the 21st is actually equal to I when you simplify that down. I to the 26th. So we take 26, my exponent, we divide it by 4. So 4 goes in there 0 times, 4 goes in there 6 times, 24, with a remainder of 2 this time. So 2 is your new exponent on I squared. And what is I squared? Well, going back to my little cheat sheet up here, I squared is -1. I will be referencing my cheat sheet up here. Make sure you know that, because I'm not going to be sliding up every time. So I squared is -1. So this actually ends up being -1. I to the 35th. Okay, let's see what we've got here. So I take 4 and I divide it into 35. So it goes in there 8 times. 8 times 4 is 32 with a remainder of 3. So it is actually really I cubed. I cubed would be -I. And there you go from my cheat sheet. That's how we simplify these things. We can take a look at some simplification with some distribution as well. You might have something like I to the 5th times 2 plus I. So the first thing you want to do is you want to simplify I to the 5th. So you divide it by 4. Okay, I have an exponent of 1, so it's really just I times 2 plus I. Now we would distribute 2I plus I squared. You're thinking, oh, I squared. Okay, back to my cheat sheet. I squared is -1. So it is actually 2I plus -1. Okay, I'm going to put my real part first and my imaginary second. So it would be -1 plus 2I as a simplified version. How about I to the 10th times 4 plus 3I? So I to the 10th, so 4 goes in there 2 times, remainder of 2. Okay, so this is really actually I squared, 4 plus 3I. And we're looking at that, and I squared, okay, so I squared, back to my cheat sheet up top, I squared is -1. So -1, 4 plus 3I. Distribute that, -4 minus 3I. Real first, imaginary second. Okay, I'm going to keep going with this now. So you have probably seen something like this. In your life, it is a number, and that is the number 5. That number is considered a real number. You have now been introduced to something like this. -3i, that is an imaginary number. If you take a real number and an imaginary number and you put those two together, you end up with something that we call a complex number. That is a complex number. The real comes first, and the imaginary comes second. That's just the rule. That's how we do it. So each complex number has a conjugate. If that's the complex number, we also have a complex conjugate. And what the complex conjugate is, you change sign of the imaginary part. So, for example, if this was my complex number, 5 minus 3i, the complex conjugate would be 5 plus 3i. Sign change. If we had, let's say, 2 plus 7i as a complex number, we would change the sign on the imaginary to minus 7i, and that would be our conjugate. Negative 8 plus 3i, the conjugate would be negative 8 minus 3i, only a sign change on the imaginary part. If we had 4i as my complex, I would change the sign on the imaginary, and it would be negative 4i. If I was looking at 7i, or negative 7i as my complex conjugate would be positive 7i. Now, what is nice, you might be asking yourself, why do we deal with conjugates, or why do we have to deal with conjugates? Let's say we have a complex number, 2 plus 3i. We could take this number and we could multiply it by its conjugate, its complex conjugate. So I could multiply this by 2 minus 3i. So there's my complex number, multiply it by my conjugate. A lot of people stay organized like this, using a box, an area model to show your multiplication. If you distribute, it's going to end up being all the same thing. So 2 times 2 is 4. That is a positive 6i. That would be a negative 6i. And down here we would have negative 9i squared. Well, those two cancel each other out. That's nice. And back to that cheat sheet up top, I squared is actually negative 1. So this box right here is negative 9 times negative 1. So this whole box actually ends up being a positive 9. So it is 4 plus 9, giving me a value of 13. So when you multiply by the conjugate, the imaginary part disappears and goes away. Negative 3 plus I. Let's say that is my complex number. Well, we could multiply it by the conjugate, negative 3 minus I. So if you want to use your box to stay organized, feel free. Negative 3 plus I, negative 3 minus I. So that is 9, negative 3i, positive 3i, and down here you get negative I squared. Cancel. Negative times that I squared, which is negative 1, that ends up being a positive 1. 9 and 1 is equal to 10. That's very nice. Handy little trick right there. And the way that you typically see it in action is something like this. 2i over 3 plus 2i. You don't want to leave any imaginary numbers downstairs in that denominator. You want to get them out. Think of it kind of like rationalizing the denominator here. So I can multiply top and bottom by the conjugate. 3 minus 2i. 3 minus 2i. Because I've really just multiplied by 1, and you are allowed to do that in math. So the way that you stay organized, we get 6i minus 4i squared. That's my numerator, and you can simplify that. You get 6i. My I squared is negative 1, so negative 1 times negative 4 is actually positive 4. Now always rearrange these with the real part first and the imaginary second, so you get 4 positive 6i. You could come through and you could factor a 2 out of there, and you would end up with 2 plus 3i times 2 as your numerator. Now we deal with the denominator. So 3 plus 2i times 3 minus 2i. I get 9, 6i, negative 6i, negative 4i squared. I squared is negative 1. Negative 1 times negative 4 is a positive 4. Those two cancel, and you are ending up with 13 as your denominator. There you are. Sorry about that. We'll do one more of those, just for fun, because it is so much fun. 2 plus I over 3 plus I. We don't want to leave any imaginary numbers downstairs, so let us multiply by the conjugate. 3 minus I, top and bottom. So my numerator, 2 plus I, 3 minus I get 6. We're looking at 3i, you're looking at negative 2i, and negative I squared. Bringing everything together, we get 6 plus I And this would be negative times negative 1, which is a positive 1. Really, 7 plus I is my numerator. Working the same thing with the denominator. 3 plus I, 3 minus I with its conjugate. 9, 3I, negative 3I, and negative I squared. I squared is negative 1 times negative positive 1. You two are canceled. We are ending up with 10 downstairs. 9 and 1 is 10. Hope that helps. I appreciate it. See you next time.